trick. The only way for you to become good at writing functions is for you to practice. I cannot emphasize that enough. And you are going to see why I'm saying that in just about a few minutes. If you don't write functions, you cannot be good at functions. Then the second thing is that start with very simple functions and then build gradually to more complex functions. For instance, a simple function is like a function that says hello Dorcas or hello Lily. Okay. Then we can also talk about more complex functions such as a function that calculates the factorial of a certain number, which is quite complex. We'll come to that as we proceed. Then finally, you need to broaden your math knowledge. I'm not saying that go and become a mathematician like Dorcas or something, but then just have a fair knowledge of basic math, okay? Like you know what square root is, you know what exponent is, you know what power, like basic math functions, like how to calculate the area of certain shapes. Like you know that the area of a circle, sorry, yes, you know how to calculate the area of a circle. You know that is pi r squared, you know, stuff like that. You know that a triangle is base times height. You know that the way to calculate the volume of a circle is 4/3 pi r cubed. You know, stuff like that. These are basic things, but you don't have to memorize them necessarily. Just know that sometimes you need some of these things. So you can always go to Google. How do I calculate the area of a parallelogram? Then the answer will come. Then you now know how to implement it in code. So with this foundation set, let's just go right in. What are functions? In C programming, a function is a self-contained block of code that performs a specific task. Don't worry about all these plenty things I've written here. Okay, let's just try and demonstrate a bit and then understand what I mean by that. So let's just say we wanted to create a box. Okay, we're going to create, let's say, this box, which is the program that we want to write. And this box is going to contain so many ingredients, or instead of ingredients, let's say it's going to contain so many shapes. So we are going to be writing a program. And then when we get here, we have to draw a certain complex shape. Sorry. Let's say we're going to draw a square with a circle within it and a plus sign in between. And we'll have to draw it here when we get here. As we continue writing our program, we have to come to a place where we create another shape. Let's say it's a square with a triangle within it with a dot. Or let's say we have to create another shape, a square with a circle with a triangle within it. Various complex shapes. Okay, let's say a square with a cross sign within it. So now I'm writing my program, and when I get to this point of the program, I have to implement a function. Okay, now I'm trying to write this function, let's say this first function. Okay, so now I have to take my time, draw this shape, and get it exactly as I'm going. Then I continue with my program. Then I have to implement another function again. So now I have to take my time and draw the same shape and then take my time. See that I'm wasting a lot of time. Then I have to continue my program. Let's say I want to implement the next shape. I have to take my time and draw it, and then I'm trying to implement. So you see, I'm writing a program, and these things are becoming repetitive. Okay, so instead of worrying myself, now whenever I get to a point where I want to implement a certain task, why don't I rather assign names to all these shapes, so that when I get to the point where I have to implement any of these tasks, I will just call the name of these shapes, and then they will be produced instantaneously for me. So for instance, now instead of, just give me a moment, across, okay, and we are creating this soup. Now, instead of getting to the point, then I have to implement this program, I can just assign names to this. So let's call this A, let's call this B, let's call this C, and let's call this D. All right. So now when I'm writing my program, when I get to the point where I have to perform this task, instead of taking my time to draw to waste time, I can just call A. And then when I call A, everyone or the program, the system that I'm operating in understands that, okay, A represents the shape of a triangle. So I don't have to take my time and draw that shape. And as I'm writing my program, I want to implement this shape or task. So I'm going to call B. I want to implement a circle. So I'm going to call C. In a pictorial view, basically, this is all functions are about. Functions make your life easy. Okay, they make tasks that you are supposed to do repetitively and then struggle to implement 100 lines of code at every point. All you have to do now, let's say I have 100 lines of code. Now I'm trying to implement this task. Then I have to come back and write 100 lines at every point when I have to write this task. But what if I assign a name? Let's say I assign a name Y to this block of code that does a specific task. Now, when I'm writing my program and I have to do all this with 100 lines of code, all I have to do is to write Y. And the program understands that this function Y will execute the entire block of code in this program. This is the power of functions. They make your life really easy. Okay, so if that is well understood, let us go forward and then continue our studies. Please, are we all on the same page? Are we on the same page? I wish I could get some responses from people.
Yes, we are.
Yes, yes.
All right, great. I can continue. So now let's talk about.
Yes, sir.
All right, I heard you. So let's talk about how to write functions. The way to write a function is the easiest thing in programming. If else, arrays and all that are even more difficult than functions. But if you understand how to write and use functions, you become one of the strongest programmers that exist in the world of programming. And you only need 4 things to declare a function. Number 1, you need the name of the function. Number 2, you need a return type of the function. You understand what this means. Number 3, you need the parameters. We're going to talk about parameters and arguments. And number 4, you need the body of the function. These things are really simple. You can write them down. So to declare a function, this is a syntax that you need to declare a function. It is as simple as number 1. So you bring the return type. You understand what the return type means in a bit. Don't worry. Then you bring the name of the function. And if you want to include parameters in a function, you bring it. Then you put the block of code inside curly braces, and that is the body of the function. Okay, so return type, the name of the function. If there are parameters, you bring them, because not all functions have parameters. And then your code that you want the function to execute will be inside the curly braces. So what are the return types? They indicate the data type of the value that is returned by the function. So let's say you want your function to return an integer, a float, or any data type at all. This is the place where you indicate where your function, where you want your function to, the kind of data type you want your function to return. All right. Then the next thing is the name of the function. I think that's quite straight to the point. Then if you do not want your function to return any data type, then you use the void. And I'm sure you guys know what the void is now. And the final thing is the parameter list. We're going to understand what that means. Okay. So before I go into practical coding, let me say one last thing. Naming your functions are the same as naming variables. I'm not too sure. I wasn't in the class when you were being taught about variables. Okay. But I would assume that you were told that there are proper naming conventions for variables. Okay. For instance, you cannot try naming a variable and you just come and say, let's say, first name. No, you can't do this for naming variables because it's inappropriate for you to create a variable with spaces in between them. Okay. Neither can you name a variable and say one number. Let's say you are creating a list of numbers and then you say 2 number. It's not appropriate to start variables with numbers. Okay, it is very wrong. So the same way you name variables are the same way you name functions. There are naming conventions for functions, just as there are naming conventions for variables. And then in every programming language, you also have to understand that there are reserved words. Okay. So just as you cannot just name your variables and functions anyhow, you cannot also use reserved words for variable names and function names. You have to keep that at the back of your mind. So these are some proper ways of naming variables and functions. You can decide to use a camel case. So for instance, you want to declare a function or you want to declare a variable that calculates the first name. You can decide to go with a camel case. So let's say you start with a small letter and then the next word starts with a capital letter. So you can say house address. This is a very good naming convention for variable, and this is known as the camel case. All right, a very good naming convention for variables. Then you can also use underscores to name your variables. So let's say you want to declare someone's first name, just say first underscore name. This is also a very proper convention for naming variables. All right. Then you can also use words and numbers. However, when using words and numbers, always make sure that the words come first before the numbers. So let's say I'm declaring 3 numbers. I can say number 1, number 2, or number 3. This is a very proper way of naming variables. Never bring the numbers first. Always bring the words first. All right? And that makes it really cool. Then number 3, use descriptive names for your variables. For instance, you want to declare somebody's last name. Let us know what your variables and your functions are doing. Don't use random things like, let's say, X, Y, Z, like X. No, nobody will know what this function or this variable is going to do. So for instance, if I want to create a function that calculates the area of a circle, personally, I would want to name it like circle area. You see, the moment you see this, you can tell that, okay, this function or this variable does this specific task. Okay, so now we know that, okay, this variable, this is going to calculate the area of a circle. Or let's say I'm going to find out the area of a triangle. So I can say triangle area. This is, I'm using a camel case, as you can see over here. Use descriptive names. Wonderful. And like I said, don't separate the name of your function and variables with spaces. Good. Now, I think we've laid needful and essential foundations. I could have just gone straight into just getting our hands dirty. Let's code. But I'm the kind of developer who understands implementation. I always want to know the underlying working of what I'm doing, so that when I run into errors, I know exactly what to solve my problems. So I want to lay these cardinal foundations so that when we start coding, you understand that, oh, this is this. I understand why this is working this way. So there are 2 very important kinds of functions. Now over here, I want you to pay cardinal attention, because when you lose me here, you might as well go out of the class, because you won't get the rest of the things I'm coming to say. I'll be making some statements and you lose me out. So please, whatever you are doing, I need your ear over here right now. Give me all your attention, because I'm about to say a few things, which is the foundation of everything we are going to do next. Okay? There are 2 kinds of functions. The first one are user-defined functions, and the second one are standard library functions. I'm going to repeat it again. I said that there are 2 kinds of functions. There are user-defined functions, and those are the functions that you can create on your own. Okay? Then there are functions that are already predefined in the C programming language. So for those functions, all you have to do is to call them. Remember what I showed you? There are some things that have been done for you already. You don't have to struggle. No need to struggle. So we are creating this soup. Seasoned programmers, senior programmers in the ages past, like Dennis Ritchie and Ken. They have taken their time to create functions for you. So let's say if you wanted to do a very complex, I'm sorry, something funny just came to mind. That's why I'm laughing. Okay. So let's say you wanted to draw a very complex shape, like a caricature, a face with eyes, which is a function, with ears and hair. Okay. With leg and everything, and breast. All right. Okay. So seasoned programmers have taken their time and they are written all these functions for you in the C programming language, and they have given it a name. So when you come to a certain point in your programming where you have to implement a task, all you have to do is to give it the name that they have given to that function, and it will do everything for you. We are going to see practically in a moment, so don't worry. So let's say Dennis Ritchie has created this function and he called it main. Okay. Now you understand what main is in a moment, and you have actually been using it all the time, but you may not have realized that, oh, that's a function. Okay. Then another function which you have been using all the time is printf. Okay. And this function prints out the output of a program. And people have taken their time to write functions that performs tasks for you. Now, this printf that we have been using to print out code all the time, actually, this thing is an entire code on its own. If we are to take our time to break down the code that powers this printf function that you use to just print things on your screen, you'll be amazed. So this printf we have been using all the time is an actual function, and people have taken their time to sit down to write the code that powers this function. Okay, those are called standard library functions. All right. Now let's go back into our Evernote and understand what we are talking about here. Good. So like I was saying, there are user-defined functions and then there are standard library functions. An example of the standard library functions, like I told you, is printf, there is main, and then there are so many of them, as we will see. As for user-defined functions, you can create 1,000,001 of them. So some common examples of functions are, for instance, the int main. Whenever you're about to write a C program, automatically you start doing stuff like this. Okay, so let me include the standard inputs and outputs.h. Why do we do all these things in the first place? Can't I just go ahead? Okay, I want to write my function. I want to print. I just print. What is the essence of all these? Okay. Then when you are done, you come and do int main. Then you bring your curly braces. You return 0 before. Let's say if you want to write a function like hello world, now you come and printf hello world. Okay. So I'm gonna printf. Let's greet hello Lily. Okay. Now, so why can't I just come straight to this and then say that printf? Now I have to come and include something, declare my code inside a function. There is a reason why, and that is because this int main you are seeing over here is the format of declaring functions. Remember that I told you that the syntax for declaring a function is that you bring the type, the data type or the return type, the name of the function, the list of parameters in parentheses, and then the code of the function. And that is what you have been doing all this while in writing your C program. You just bring the data type of what the function should return. This time around, you realize it returns 0, okay? Then you bring the name of the function. So the name of this function you have been using to write your C code is known as main. Then after that, there is this parenthesis over here, which you can decide to put parameters in there. You understand what that means. And then every code that you've been writing all this while in your C programming, you write it inside the main function. But today, I'm going to make you a rebel, all right? You are going to be rebels today. We are going to defy the normative way we've been writing code of always writing things inside main. Every day, write it inside main. No, today we are going to break that rule. We're going to write functions outside the main function because now we have come of age. Okay, we can declare our own functions now. So we are going to escape that main thing and we'll write our functions outside of the main. So let's go into my Visual Studio Code. Okay, let's go into my Visual Studio Code. Where are you? Visual Studio Code. I can't find my Visual Studio Code. Okay, just give me a minute. Let me find my Visual Studio Code. Here you are. So I'm going to open my Visual Studio Code, and then we are going to write some C programs and create some functions. All right. Let's not get too complex. So let me create a new file. Let's call it functions pass. Okay. .c, because it's a C file, and I enter. Wonderful. So let me get rid of this. Okay. And then let me also get rid of my terminal and increase the fonts of our IDE, and let's get our hands dirty. Okay, so let's just bring in the basic structure of our C program, which is to include I'm going to explain today. I'm going to explain what this thing means to you when we get deeper into functions a bit. So we're going to include the standard input and output.h, the header file. Okay. Then when we are done, we'll declare our function, which is int main, then parentheses, then we bring our curly braces, and we declare our code over here. All right. So this is going to be our code. This is what we have been doing all this while in writing C programs. But today, let's break the rule. Instead of writing our code inside the int main, we are going to create our own function. It is in that you are not going to realize that, oh, so this thing over here is actually a function that we have been calling and calling all this while. So let's create a simple function today. Let's create a function that greets all of us here. Okay. Now, to create a function, remember I told you that you first have to bring the return type, which is the data type. So for our first function, we are not going to worry about the data type because we are beginners. So let's take one step at a time. Baby steps, baby steps, baby steps, baby steps, baby steps, baby steps, baby steps. Okay, all right. So we're going to take baby steps. So for our first function, we're just going to void it. So the data type is now void. Okay, so this time around, no data type. Then we're going to bring the name of the function. Let's call it greeting or greet. All right. Now, like I told you, when you're done with the name of the function, you bring your parentheses. And you can put in content inside the parentheses. But for now, since it's our first function, let's just take our time and then leave empty. So no parameters for this function. Then now our code is going to be inside this function. So we're going to print f. And we're going to say hello justice. Okay. Then as usual, you bring your semicolon. Wonderful. Then when you're done, so basically, as you can see over here, we have created our own function called greet. And I've configured my VS Code in such a way that my functions are printed in green. So whenever you see green, just know that we are dealing with functions. Whenever you see yellow, we are dealing with strings. Whenever you see pink, then you know that we are dealing with a data type. So when I type any data type, you're going to see it in pink. And whenever you see this blue, it means it's a comment. Okay? Just to make things very clear for you as we proceed. So I've created a function, and this function is called greet. The function says, the purpose of the function is to say hello justice. Okay? Now I'm going to come into my main code. Then I'm going to see if we can probably use this function. Okay? So the way to use a function is to call the function. Remember what I told you in our code. When we sketched our beautiful programs, I told you that, where are my beautiful babies? They're gone. They've been replaced by this one. Okay. So I told you that when you have created this complex shape, and you want to use it, all you have to do is to call it. Let's say the name given to the shape is A. So all you have to do to use this function is to call A, then it will do everything here. Now, inside our code, we have written a function that prints hello justice. The way to use a function in our code is to call it. So we are just going to say greet. Okay. I bring my semicolon. So we wrote a function that is called greet. The name of the function is greet. And then we are calling the function to perform an operation over here. So let me run my code and see what happens. And you're going to realize that one error generated. I don't think I brought a semicolon somewhere. So let's get rid of this and go correct that. So void greet print hello world. Let me run my code and debug. Now you remember that I told you that when you are writing functions, one of the cardinal skills that you would need is debugging skills. Okay, so one of the cardinal things that you always want to have under your belt is the ability to be able to debug your code. So it says that expected identifier or parenthesis. Let me go look for it. Okay, I think I have my parenthesis here. Then I have it here too. Okay. Oh, then I have to return 0 here. Okay. Let's return 0 as our usual C program. And let's run the code again and see what happens. So as you can see over here, hello justice has been printed. I wish I could maximize this a bit for you. So just look down here, you're gonna see that hello justice has been printed. Let me put it on a new line, then run the code again. You know what? Let me clear my terminal so that we good. Now I'm gonna run the code again. And as you can see, hello justice has been printed over here. Okay. Over here, I didn't say when I called my function, I didn't say hello justice or something, but the moment I run the code, hello justice is naturally printed. That's because when you call your function, it goes all the way up and then looks for the function that you called and executes the content of your code. Let me show you what I'm talking about to demonstrate. I'm going to delete this. Okay. So I'm just going to get rid of this. Wonderful. And I'm going to run my code again. Before I do that, let me clear my screen so that my terminal. Great. So I'm going to run my code again. And you realize that when I run my code, nothing is showing over here because I have not called the function. The fact that you have created a function does not mean that when you run your code is going to show. No, you need to call your function. Always have those sketchy things I drew on the sketchboard in your mind. We have a big cupboard, and this cupboard is full of so many things. They are called functions. This cupboard is full of so many shapes. It's full of so many fruits. It's full of so many ingredients and recipes. Okay, so now they are stuck inside the cupboard. But if you want to use any of them, you have to reach out for them. So we have created several functions and they are housed somewhere. Now, for you to use any of these functions, you need to call them or you have to reach out and take one of them and use it. So here in our code, what we did was that we created a function that says hello justice, but we cannot use it because it's inside a cupboard, it's stuck. Now for us to use it, we have to come inside our int main function and then we have to call it. So when we call the name of the function, remember we named the function greet. When we call the name of that function and now we run our code again, then we have hello justice printed on our terminal. This is the basic understanding of functions. And as simple as this is, it can get complex and complex and complex and complex to the extent that you start going crazy. Okay, so I'm going back into my Evernote and then let's just try and solve a few examples. We've done this, we've done this, we've done this. Let me minimize this a bit. We've talked about naming. All right, I'm going to run through this so that you have things stuck in your mind. I said that broaden your math skills. Functions are self-contained block of code that perform specific task. Okay, it helps you break code into smaller chunks. All right, and write a function that calculates the area of various shapes. We've done that. Then for a function, you need to have the name of the function. You have to have the return type. You have to have the parameters and then the body of code of the function. And this is a syntax of a function. You have the return type. You know what that means in a bit. Then you bring the name of the function, the parameters, and then the body of the function. So for the function which we just wrote that says hello justice, it does not have parameters. So this was empty, as you realize. The function wrote for justice didn't have parameters, and also we said hello justice. Let us go and try and write a function that actually has parameters. And do not forget, I also define functions and standard library functions. Okay, awesome. And these are some examples of standard library functions. They've been written for you already. You don't have to write them yourself. Okay, now we are dealing with, so everything we are going to be doing right now are user defined functions. Later on, we are going to go into standard library functions and how to use them. But for now, we are going to write our own functions because we have come of age. We want to tell our father that we don't need an int main anymore. We are going to declare our own functions and use them. Okay, so now we wrote a simple function that greets somebody, and then to call the function, you use the name of the function and then parentheses, and then you have the function executed. Let's just go and try functions with parameters and then see what they do. So for that, let's try and write a function that calculates the square of a number. All right, let's just go and try that in our code. So now over here, we're going to try it's another function. Previously, hitherto, we have been writing all our codes in the int main, but like I told you, we have come of age now. So we are leaving the int main and we are writing our functions outside of int main. Wonderful. And later on, I'm going to explain to you why you need to write your functions over here before the main function, okay? You need to declare your function all the time. The moment you import your libraries, so you include standard input output.h, or you can include other libraries. The moment you are done importing your libraries, the next thing you want to do is that you want to write your functions out before you come and call the function in the main function. So this is the location. I've reserved this space for you for writing functions. Don't forget that. It's very important. Okay, now let's write a function that actually takes parameters. And this function is going to calculate, let's say, the square of a number. You can write a function that does literally anything, but we are taking it step by step. Today, we've tried a function that says hello justice. Let's try another function that calculates, let's say, the square of a number. Like I told you, you first need to declare the data type, okay? But let's not worry about data type yet. We're going to do it in our next example right now, okay? So let's forget about the data type still and still say it's void. So we don't care about the value that's going to be returned yet. We're going to care very soon, but for now we don't care. Okay, so the data type is void. Let's remember that you're supposed to use descriptive names for your functions. So we're going to calculate the square of a number. So let's call this function square number. Make sure your functions and your variables are always descriptive. So now, since we're going to square a number, we need to provide a parameter. That is the number which will actually be imputing to be squared. Okay, so let's call this number. Right? When we are done, you bring your curly braces, and then your code goes into the curly braces of your function. Then you can decide to create a variable and assign the calculation of the function to it, or you can just write it raw. It really depends on what you want to do. Okay, so let's create a variable which is an integer, and let's call it result. Okay, let's call it result. Then we assign it to the calculation of the code which we want to be executed. And this time around, remember, you need to follow your mathematical knowledge. We are calculating the square of a number. What is the square of a number? It is the number times the same number. So 2 squared is 2 times 2. 4 squared is 4 times 4. 9 squared is 9 times 9. Mathematics, simple math. So now we are calculating the square of a number. We are just going to multiply the number by the number by number. Don't forget your semicolon. If you don't bring your semicolon, your blood is going to dry. Okay, now let's print the results. So let's printf results. Okay, you guys have learned about format specifiers, right? So let's play with some format specifiers here. Okay, so let's say the result is %d. Okay, then let's bring the name of the variable, which is results. Okay, bring a semicolon. What is going on here? What is going on here? We are creating a function. You bring your return type or data type, not to confuse you. Then you bring the name of your function. You are free to choose any name. You can call your function from heaven to hell. Choose the name of your function. Just make sure that it's descriptive enough. When you are done, depending on whether your function is going to take a parameter or not, this parenthesis could be empty or full. But this time around, we are going to calculate the square of a number. So we need the number to be able to calculate its square. So you will need parentheses. When you're done, all your code is going to go inside the curly braces, the code of your function. So what we did was that we created a variable, which is an integer. We called the variable result. You can decide to call your variable anything. I am the one who is choosing to call it result. Okay, I could have called it Dorcas. As a matter of fact, let me call this variable Dorcas. Okay, and then Dorcas calculates the square of a number. So it's number times number. And when I'm done, when I was done, I want to print out the result of my calculation, which is the square. Okay, then this format specifier is just what it's like a placeholder for the integer. I'm sure you guys have already learned about this, so I'm not going to talk about it. And then when you are done, you bring the name of your variable, and we have changed it to Dorcas. So remember, this is how it's supposed to be. Okay, I'm done. But if I run my code right now, nothing is happening. As a matter of fact, we are very stuck. Nothing is happening. Just some random things over here. Let me clear my screen. Let me hide this. Okay, great. Good. Nothing is happening here. I'm going to run my code again. Nothing. All right. So I'm going to get rid of this. And the reason why nothing is happening is because I've not called my function. What is my function? The name of my function is square number. That's the name of my function. So I need to call him before he can shake himself. Okay. So let's call him. Let's call square number. Here you are. So we're going to square number. And then we want to square the number, let's say 4. Okay. Now, I need your attention here again. I need your full attention here again. Let me go and mention somebody's name. Who do we have here? Jimo, I need your attention. Jimo, I need your full attention. Please, I'm about to say something that you are going to be asked in your interview question. Because when I went for a certain interview, this is one of the questions I was asked. Okay? So I need your attention. Please. When we created our function, we put a certain parameter here, okay? But when we were calling our function, we have put a number over here, okay? There is a name given to the number you have put here and the name given to what you declare over here. Now, the question that the interviewer asked me is that, what is the difference between the one you put here and the one you put here? And it's very simple. The one you put here is called the parameter, and the one you put here is called the argument. Okay? So I'm going over it. When you declare your function or when you create your function, you can either decide to add a parameter or not. The parameter is like the placeholder. You are just telling your function that there is something supposed to be here. It cannot be empty. And this time around, it's just a number. Then when you are calling your function, the name of our function is Mr. Square Number. So when we are calling our function, we have already said that something must be here. So if you leave this empty, let me leave this empty and run my code and look at what it will tell me. So as you can see, one warning generated. Look, it says that square number is showing me an arrow over here that you said that something should be inside a square number. Some parameter should be here. So you cannot just leave it empty. Please put something in there. Okay. So now when you create a function, you indicate that it should have a parameter. When you are calling your function, you have to put a value in, and that value is called an argument. Argument, like the way you have an argument with your mother, or like the way a boyfriend will have an argument with a girlfriend. So I'm going to put in a number, and this number is known as the argument. I want you to get stuck in your brain, so when you go for your interview, you do well, like the way I did well. Okay, so now I'm going to run my code again, and now let's see what happens. It says that the result is 16. Look over here. Let me clear my terminal and run the code again so that we can see what's going on. Okay, so I'm going to run the code again. The result is 16. So the result of 4 squared. 4 times 4 is 16. You know what? Let me add a new line here so that it becomes clear. And I'm sure you guys understand how to add new lines, so I'm not going to talk about it. Great. So we run our code again and it says that the result is 16. So I'm going to get rid of my terminal. What did we do here? We created a function called square number. I chose to call it that. And then we came to declare what the function does. So I call you square number. Now I want to define your duty as square number. And to square a number is the number times the number. And I assigned it to the variable called Dockers. Okay. Then when I was done, I printed out Dockers, which is the name of my variable. So when I come into my main function or my main code and I call the function and I give it the parameter, it performs the function which I wanted it to perform. So let's try another number. And then, so let's say we want to square the number 5. Let me run my code again and let's see what happens. So it says that the result is 25. As you can see over here, the result is 25. So we have created a function that takes one parameter. However, you can create functions that can take limitless parameters. You can create a function that will take 1,000 parameters. First, we wrote a function that says, hello, Justice. It took no parameter. And now we have written a function that says that takes one parameter and it calculates the square of a number. Let us try another function that takes 2 parameters. When we are done, I'm going to leave you alone to try a function that takes 3 parameters with the same principle I'm going to teach you with the 2 parameters. Okay. So let me get rid of this. Let me just delete all this. Okay. Then let's get rid of Mr. Square Number. And then we are back to our normal C that we know. This is a normal C that we know. Now, we're going to create another function. This time around, this function is going to add 2 numbers. So let's create a function that adds 2 numbers. As I'm giving you this simple calculations, so please don't be too happy, because nobody in the future is going to tell you to, okay, let me not scare it. Okay. But all I'm trying to say is that these are the very basics. This is like the least of the least you can do with functions, because you can write a function that can calculate how long it will take a spaceship, a rocket, which launches from Earth, how long it will take that rocket to reach escape velocity in orbit. You can write a function that powers that spacecraft. And just to give you a fun fact, okay, I've forgotten the year, but then the Mars rover that was sent from Earth to Mars to go and explore the surface of Mars, the code that was written to power that Mars rover was written in C programming language. That is wonderful. 5,000 lines of code was written into the Mars rover that was sent to Mars to be exploring the surface of the planet. So, and I'm very sure that that device or that spaceship will contain serious functions. Okay, serious functions, because the spaceship must know when I get to escape velocity, what do I do? Because it must calculate the distance. When I get to the planet Mars, when do I deploy my parachute? When do I deploy my parachute? At what point in time must I deploy my parachute? Because the thing is out there, you can't go and control it. So you have to write the code in the machine that will execute it at a certain exact time to the millisecond. So if you miss one, if you make one mistake, you have thrown billions of dollars away. The billions of dollars that was invested. So let's say the software engineer that wrote the code of the machine or the spaceship that was sent to Mars to go and explore the surface, if he made one mistake with one of his functions, he was going to be fired, and he would have caused a great loss to the state. That is the sensitivity of what I'm teaching you right now. The basic foundation I'm laying for you right now. It is very sensitive, especially in the future when you're working out there, you have been given a job, you have to create a function that is going to be used in a certain hospital. And exactly in the 0.0001 millisecond, someone's pacer, which is going to be implanted into his heart, is supposed to beat. So it's supposed to synchronize with the person's heartbeat. You have to write a function that marks the time and beats exactly according to the person's heartbeat. and you go and write a mistake, and then your code is not working in the person's heart. You have killed a human being. And I blame you for not taking this class seriously. Okay, so that's just by the way. So let's try and write a function that takes 2 parameters. Okay. Now I told you that to write a function, what you have been used to is to write your code in here. But right now you have come of age, so please come out of the main and write your functions on top of main. Later on, I'm going to teach you how to write functions in here. But for now, all you need is to stay outside of the main and write your functions outside of the main, because now you have come of age. So we're going to write a function that adds 2 numbers. What did I say you must do first when writing a function? You must declare the return type. That is very important. And for this one, I'm going to come with an integer. Previously, we have just been doing void. But this time around, we are declaring that we want our function to return an integer. The moment you do this, the rules are about to change. When you say void, nobody cares about what's going to come forth, because no one cares about a data type that should be printed. But as soon as you declare a data type, let's say you want a character to be returned, car, or let's say you want a boolean or a float, a double to be returned. The moment you declare a data type, then you have done something specific, so you need to pay attention. Now, so I'm going to say that for this function, I want a return value, which is an integer. I'm taking you back to my Evernote, and I'm going to show you the syntax of a function. I told you that to declare a function, you first need your return type. You bring the function name, the parameters, and then your code inside the curly braces. I'm intentionally going back to it over and over. It's not to bore you. I'm trying to entrench it in your brain. That's how programming works, okay? So this time around, we have declared a data type, and let's give our function a name. Like I told you, use descriptive names. Previously, we have been using a camel case. Let's try another one. So let's use underscore for this one. So we are going to call this function add number, okay? Then the next thing you want to do is to declare your what? I want to hear you say parameters. Yeah, I heard you say. Okay, so your parameters, this time around, we are taking 2 parameters. So let's call this num1 and let's call this num2. Okay, don't forget to bring your curly braces, enter, then your block of code comes inside the curly braces. Okay, so now we are going to tell the function called add number what it's actually supposed to be doing. I can either decide to create a variable and then give the execution to the variable, or I can just go straight to the point. But the advanced and proper way to do it is that always store your calculations in a container, which is a variable. Don't just leave them walking about like wayward children. Anytime you want to do something, calculation, complex, arithmetic, keep it in a container so that it doesn't scatter. This is proper convention for coding and programming. As simple as they seem right now, today, in the future, you are going to see how important creating variables and keeping things inside them. Don't know. Okay, that's just by the way, I'm just having fun. So let's create a variable which is going to be an integer. Let's call it sum, okay? Because we're going to sum numbers. You don't have to call it sum. You can choose any name for it. But I'm taking the name sum because I like to describe my variables very well. Anyone who sees my functions and my variables should know what they are doing. So we are creating a variable called sum. And then we are going to give it what it's supposed to do. It is supposed to add number 1 and number 2. Okay. These are our parameters that we told our function we want it to do. And this is what our function is going to be doing. It's going to be adding 2 numbers. Don't forget your semicolon. Your semicolon is the most important thing in C programming. Then, when you have done telling the function that you are supposed to add these 2 numbers, previously, I need your attention here again. Let me go and mention somebody's name. Peace. I need your attention, peace. Okay. All right. Previously, what we have been doing is that we just do printf, blah blah blah, and we print. But this time around, we are not going to do printf anymore. You have come of age. please drop the printf for now for functions. You are not going to use printf again when declaring functions, because it is not a proper way of writing functions as you are progressing your programming journey. When you start, you are practicing, be doing printf to write your functions. But please, after this example, we are not going to do printf for functions anymore. Now, what we are going to do instead is that we are going to return our function. Okay? Said that. Now you're going to return our function. So what are we returning in this case? We are returning this variable. So return sum. I bring my semicolon. And I'm done writing my function. I'm going to go over it again. So I brought my return type. I want my function to return an integer. It's like the data type of the value that the function is going to return. I'm saying it again. The return type is the data type of the value the function is going to return. Then the next is the name of the function. Then the next is the parameters. You bring the parameters that the function will take. Okay. Then now the next, inside the curly braces, you declare the exact execution the function is going to do. When you are done, now you need to return your function. So assuming I didn't use an integer here, okay? Assuming I just left this open, okay? I just came down here and said num1 plus num2. Then there's nothing to return. So I'm just going to return my function, add number. Okay. I'm just going to return my function. But don't do it this way. No, don't do it this way. Or else you have let your student wayward. Keep them in variables. All right. So we created a variable called sum, and we kept our functions inside those variables. And now we are going to return the function, the variable sum. So what sum does is that it adds two numbers, number 1 and number 2. Wonderful. When you are done creating your function, now you come inside your main code, your main function. You come to call your function. Like I explained to you earlier, you need to call your function. If I run this code now, boom, nothing will, there's nothing, because we've not called our function. So let's call a function. We're gonna before we call a function, let me make it simple for you. Before I make it a little advanced, let's just print f. Okay, and we'll say the sum is %d, and you know why I'm using this %d, I assume you know. Okay, then look, that's just the sum of, let's just say the sum of %d, you %d and %d is %d. Okay, then we bring in our variables and we say the sum of num1 and num2 1 num2 is %d, which is the sum. Okay. Oh no, just a moment. Forgot to tell you something very, 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 very important. In C programming language, you must always bring your data type. Must always bring your data type. So now when I'm bringing in my parameters, I have to indicate that this parameter is an integer, this parameter is an integer. And then when I'm summing them, I need to already declare it, so I don't have to bring it here. Wonderful. Great. So let me create a variable for 2 numbers, and then we are gonna use them to run this function. So I'm gonna call my function add number. Okay. Name of my function is add number. And then remember that you're supposed to put in your parameters, which are the 2 numbers over here. And when you put in the numbers over here, they are called arguments. So let's say you want to add 4 and 5. Okay. Great. Then we have called our function, we are adding 4 and 5. So let's print f the sum of, because I didn't create variables, I'm just going to get rid of this. A semicolon. Okay. So I'm going to assign, I just want to make things really contained. That's why I'm just going back and forth. Instead of just leaving the function out here, when I run this code, it's going to work. It's just going to print out the value for me. Okay. Okay, great. Awesome. So instead of doing that, let me just assign a variable to this function. And let's call it result. I don't think we have result up here. Great. So let's call it results. And so now I'm assigning a variable which is an integer. So the result equals to the function we just created up here, and then we pass in the arguments of the function. And now when I'm done, I can just print f my result. So %d, I'm printing out result, my semicolon. Wonderful. So now when I run my function, it should give me the addition of, let me clear my screen and run the function again. So 4 plus 5 is 9. Okay. So that's what you're seeing over here. Let me go over it just so that it doesn't look too confusing, to make it quite straight to the point for all of us. We created a function called add number. We gave them the parameters, 2 parameters. Now, if I take out these arguments over here and run the code, it's going to pass an error. It's going to give me an error, okay? But then I created the function called add number, give them 2 parameters. Then I created a variable called sum. And then I told the sum that it's supposed to add these 2 numbers. That's a block of the code. And when you are done, you have to return the sum. This return statement is a return type over here. So the sum that I'm returning must have the same data type as my return type I declared over here. Okay. Then inside my main function, I came and created another variable called result. And then I called my function. The function is to add 2 numbers. So the moment I call my function, it knows that it's supposed to add whatever arguments I give to it. So it's going to add these 2 arguments. And then I printed my variable result. So when I run my code, it gave me the result, which is 9. Okay. Which is really wonderful. So we could even create variables and assign them to them. So let's say we create a variable int x, then assign the number 4 to it. Create another variable, let's say int y. We say it is, let's say 6. Okay. And now we want to put our variables here, y. We want to add x and y, which are variables. And now we can print a statement, the sum of %d and %d is %d. Okay. So these are just placeholders, and I'm assuming that when you did variables, you spoke about these things. So the sum of the first variable, which is x, so I'm going to bring it here. So the sum of x and the next variable, which is y, is the next variable, which is result. So when I run my code, it should give me this statement now. So the sum of 4 and 6 is 10. Let's go create a new line so that it looks beautiful for us. Let me just put a new line here. Run my code again. It says that the sum of 4 and 6 is 10. Let me even put a full stop after the new line, before the new line, and run my code again. So it says the sum of 4 and 6 is 10. So I'm going to clear my terminal and then run the code again. It says that the sum of 4 and 6 is 10. So basically, I'm putting together a few of the things we have learned, and We've seen how you can declare a function with no parameter. We've seen how you can declare a function with 2 parameters. We've seen how you can declare a function that prints a statement. But this time around, the different thing we are doing over here is that when we declared our function, we didn't print our function over here. All right, we brought a return statement, and this is the sensitivity of the return statement. The moment you bring a return statement in a function, anything else you bring after that function is null and void. It won't work. The code is not going to recognize it. So for instance, let me just bring a print statement here. So I'm going to print f, and let me just call this a statement. Okay, I'm going to run my function. Let's try and run the function and see if this printf statement is going to show. So I'm going to run it, and as you can see, nothing is coming. The same result we got, we say that the sum of 4 and 6 is 10 is the one that's showing. This statement that we just put over here, it's not, the code is not recognizing it. And that is because the moment you declare your function and you bring your return statement, you are telling the system that that is the end of my function. So when you get to the return statement, everything is over. So anything else you bring here will be rendered as null and void. When declaring functions, you have to keep that at the back of your mind. When we call that function add number, it added the 2 variables and then returned the result to us. Okay, so let me just go into my Evernote and let's see if there are more important things that you need to take care of, which I put down for you. We calculated a function that squares a number. So this is a function that takes 2 integer parameters and returns their sum. Return that. Great. Remember, I spoke to you about the return statement of functions. When you return a statement, the rest of it causes the function to immediately exit. And then it returns control to the calling program along with the value specified in the return statement. The moment you bring your return statement, which is here, your function is over. It just exits the function. Okay. So let's go. Good. This is very important. This is very important. I couldn't have left it out. All right. So let's deal with function prototypes, and then we are going to end today's lecture and solve maybe 1 or 2 more examples. Or if I pile up things on you, it's not going to help. Okay. So let's, for today, because it's a Friday night and I need to end this class and go out there and chill a little bit. Okay. I'm going to teach you about what function. Now, you need to pay attention here because in ALX, they are going to kill you with prototypes. They will always tell you, put your prototype header file, put your prototype in the header file called main.h. That is what you're going to be seeing for the rest of this course. So you need to pay attention here 100%. What are function prototypes? Because ALX is going to kill you with function prototypes. So please give me your attention here. Okay. Now, in C programming, a function prototype is a declaration of a function that specifies its name, return type, parameter types, but not its actual code. What is this thing trying to say? Let me go into my Visual Studio Code. I'm going to get rid of everything we've done. Okay, so that we can talk about prototypes. What do we have here? I'm going to delete this. Let's just get rid of all this and have our basic C program. Wonderful. So we are back to our basic C program. This is what we know. Now, you already know that when you are writing a function, you have to write the function before the main function, because this is a function on its own. You are also declaring a unique or different function on its own. So you can't come and put the function inside the main function. You can actually do that though, but we've not come to that yet. Okay. So when writing functions, you need to write the function before the int main. Okay. Now, there is something called a function prototype. Prototype is just an English word. It simply means like an example or a model of something. So I'm going to create a car. So I can create an example of the car, or let me not use the car. I'm going to build a house. Okay. I want to show my client, I'm an architect. I want to show my client that this is how the house will look like. when I am done building it. But I can't build it before I show it to him. So I have to create a prototype of the house. It's like an example of what I'm going to actually do. Okay, it's like a miniature example of what I'm going to create. And that is what a prototype does in code. When you're writing a function, you can choose that I'm not going to write the entire function over here. All I'm going to do is that I'm going to give the system a prototype, so that when the system is executing the code and comes across the prototype, it is going to immediately know that, okay, there is a certain function in this code. So let me take my time and compile it and check for errors and do everything. So what the prototype does is that it gives the compiler, and I'm sure you guys have spoken about the compiler, so you know what it means. What the prototype does is that it gives the compiler a forecast. Okay, it gives the compiler a forecast. Like, I'm telling the compiler that there's a certain function that is inside this code you're about to compile. So take your time and do it well. And that is basically what the prototype does. In advanced code, when you're doing more advanced C projects, what you're going to be doing is that you're going to realize that you will be you'll be given a unique file, and that file is going to contain only prototypes. Okay, but for now, we are not going to create a file and keep our prototypes in it. We are just going to put it right here with our functions and our codes, because we are beginners. But later on, we are going to create a unique file, and then we are going to load all our prototypes into one file. And then when the compiler is about to compile the code, what it does is that if it goes first to the file that contains the prototypes, and then let's say if there are 4 or 5 prototypes in there, it will check, be like, okay, so I understand that there are 5 functions in this code. So let me take my time and check them well before I actually go into the code itself. Wonderful. So I'm going to write a full function just like we've known. Then I'm going to show you how the prototype looks like. So we wrote a function that adds 2 numbers. So we did int, then the name of the function was add number. I'm doing it again for it to stick in your head. Okay. The name of the function is add number. The next thing you want to do is to declare your parameters. Make sure that you declare your data types when you are declaring your parameters. And the parameters are separated by commas. Okay. So int the number 1, int number 2. Let me add a third parameter for today, int number 3. Okay. Sorry, I don't have to bring 3 here. So int number 3. Wonderful. Great. We have created a function here. And usually what we'll do is that we'll now come down. We might want to create a variable. Let's call the variable sum. And let's say what our function will do is that it's going to add 1 plus 2 plus 3. Okay. Wonderful. Now, semicolon, then maybe we would want to also return sum, which is our function. Awesome. So this is the function that we know. This, when we are declaring functions, this is what we know. But this time around, we are not going to do this because we are just going to give the system only a prototype. So what does the prototype contain when you want to tell the system that there is a function here? And that is what I was saying, that the prototype specifies the name, the return type, the parameter, and the types, but not its actual code. And I'm going to change the color of this so that you see what I'm really trying to say, but not its actual code, but not its actual code. Okay. So what the prototype does is that it does everything we've already been doing, but it does not give the system the actual code. So I'm going to come down, and now I'm going to take the actual code away. So I've deleted all of this, and I'm going to leave it with only this. This is what is known as a prototype. So instead of giving the actual code to the system to run, what I've done is that I've just given it a return type, the name, then the parameters, and I've taken the actual code away. Now, when I do that, I can actually come into the main function, the main code, and then write the code over here. Wonderful. Great. Good. So I gave my my compiler an idea. So I'm telling you that, okay, so when you are compiling, take note that you're going to come across a function, and the name of the function is called add number. So I don't bring the actual code. I only give it a prototype, and then I come into the system and I write the full code that the function is supposed to implement. Then when I'm done, I can now print perhaps the value of my function. I can create variables for 3 numbers, just like I said. So int, let's say x, let's say is equal to 3. Y, let's say is equal to any number. And int x, set, let's say is equal to 5. And I'm going to create another variable called results. It's going to be equal to the function I just created, add number, and I give the parameters, let's say x, y, and z, and it wonderful. Then I'm gonna print f my results. For that, with my format specifier, send a results. With my semicolon. Okay. Why is this thing giving me a syntax error? Okay, let me take this. Yes, wonderful. So there's not supposed to be any. Good. Let me explain what's going on here for you. I'm just trying to teach you about function prototypes. Okay. So instead of writing this entire function here like we usually do, I only gave it a little information. Now, you might not see the importance of this. You're going to be like, why this? That's because it's a very simple application. It's just adding 3 numbers. But when you start writing really complex applications that does very complex stuff, that is when you see the importance of prototypes, because your code cannot compile everything at the same time and then now try and push the results to you. Your code has to first, your compiler has to first visit the prototypes and then see the kind of functions that you're going to be declaring, compile, eliminate the errors before it gives you the result. Especially when you now have to create applications that need to run very fast. You don't want to create a lot of lag time. That's when these things become really important. You might not know the use of this yet, but just know that there is something called function prototypes. And these prototypes are like a miniature part of your function. It doesn't give the thing the entire scope of the functions. It only gives it a small portion of it. Then you come and declare the code of your function inside here. Okay, so I'm going to print this and see what happens. Now it says that I have 1 error. Remember, I spoke to you about debugging. Debugging is very important. So I have to go back and find out where is the error. And it says that the error is on line 10. So whenever you are debugging, VS Code makes it very easy for you. It says that the error is on line 10, character 49. Line 10, character 49. So I'm just going to come into my code and look for line 10, which is over here. And if you like, you can count. But this is character 49. And it says that I have an error here. So why is this an error? It's not supposed to be, because the function is inside the curly braces. So int x, 3, int y, int z, int result, add number, everything looks okay here. Okay, these are my arguments. And I printf %d, okay, and the result. So this is correct. So I shouldn't have an error here. Why am I having error with this curly brace? I don't know why. Let's run the code again and see. That's strange. Okay, let me just go into my Evernote and then see. So here in my notes, I have a function that adds two numbers. Just like I explained to you, this is a prototype, okay? This is a prototype before you come and declare the main block of the function. So now you bring your function, the details of the function, and then you return the function. So everything looks okay. Int result add number. Did I call my function? Oh, I don't think I called my function. I did. That's it. Then the parameters. X, Y, Z. All right, I'm trying to do, but I don't know where the error is coming from. I don't know why this curly brace is bringing out an error. It's not supposed to be. I don't know. So let's see what VS Code is going to say. Expected a semicolon. No, there's not supposed to be a semicolon here. I really don't know where the error is coming from. All right. Return sum. You bring your arguments and you print the result with the format specifier. And that's it. Guys, I don't know where the error is coming from because it's not supposed to be a semicolon here. Let's try and reduce the arguments and see what happens. So instead of adding 3 numbers, let's add 2 numbers and see what happens. Then 2 arguments. And means that we have to do the prototype as well.
Line 17.
Come again. Come again.
Line 17. Sorry, 16. 16.
Line 16.
To be removed, yeah.
Where is the error? What's
To be removed. To be removed.
Sure.
You are reducing them. You are reducing them now. So line 16.
Sure.
I mean, you are reducing them to 2 arguments, so you remove line 16.
Oh, I think I get what you're trying to say. But then just creating a variable shouldn't be a problem. I mean, you can have as many variables in the code without necessarily using it or calling it. So that shouldn't have been a problem. Okay, let me just run my code and debug and see. So it's expecting semicolons after all my variables. So I need to give them back their semicolons. Wonderful. And I'll run my code again. It still doesn't like my curly braces. I don't know what my curly braces has done to VS Code today, but you cannot declare a function without curly braces. Okay, I don't know what's going on.
How about removing the function add number? Like remove it from its main and make it separate.
You mean I shouldn't add the function in here? No.
Yeah.
When you
put it out in
when you declare your prototype, you must actually include the function in here.
Like remove. I get like it's inside the int main parenthesis. Like everything is together.
Uh,
Like putting it outside its main function. Do you get what I'm saying?
uh-huh.
Since it's a prototype, you have to put it inside.
Exactly
No,
what I'm
that's not
saying.
what I'm saying.
It's a
So I
prototype,
don't think
right?
you get.
You mean I should
So
take
you
it
don't get what
outside?
I'm.
You mean
Yes,
I
like
should take
right
it outside the int main
thing.
function?
Yeah, the 8, 9, and 10. Take everything
Uh,
outside its main.
so let's bring it outside int main, okay? And then run our code and see what happens. It actually works. So I took the function itself outside the int main function, and then all my variables are still inside the int main function. And then I run the code and it works okay. Let me clear my terminal. We need to figure out why exactly it's that way, because when you declare your prototype up here and then you bring your function in here, it's supposed to work. But for some reason, I brought my function outside the int main, and that's what's making the code to work. So when I run it, it's producing the sum, which is 7. So perhaps it could be that when you declare your prototype, you do not have to bring your function inside the int main function. I don't know if that is the case, but I don't think so. I need to go find
Hello.
out.
Can
So
you
let's go.
can you please paste the code on in the chat for me so that I also run it on code blocks for
Okay. So I'm copying everything. I'm gonna paste it in the chat for you. Uh, okay, I just did. I just did. Okay, wonderful. So you know what? Let's go. Let's go to my friend. Okay, I have a friend. I just hope you guys can still see my screen.
Yeah.
Then let's
Yeah, we can.
great. So let's ask my friend that do I include increase the font so we can now enjoy this. Do I include the function? Okay, after declaring a prototype, adding a function to type, do I add the function name and type and parameters in the int main function? Let's see what my dear friend is going to tell me. Look at what ChatGPT says. It says that no, you do not add the function name, return type parameters of the function, the int main function after adding a function prototype. A function prototype is a declaration of a function that tells the compiler about the function name, return type, and parameter types without providing the function body. This allows the compiler to know about the function before it is defined or called in the code. After adding a function prototype, you can call the function in the int main function, passing in the required arguments as parameters. The function definition, which includes the function name, return type, and parameter type, should be defined separately outside of the int main function. Dockers, so you were right. Here is an example of how to use a function prototype. So here is the normal include standard input and output in the header file. Then this function defines a prototype, which is the return type, the name of the function, then the two parameters, which is x and y. Then after that, it now comes into the int main function and gives the argument, which is the values of the parameters to be provided for the function. Then it prints out the function, and then outside the int main function, it now comes to declare the function itself, which is the return type, the name of the function, the parameters, and then what the function is supposed to execute. So I think it's been entrenched in my mind. I really enjoy this class. We're going to try and write more complex functions, such as a function that calculates the area of a circle. Go home and try and do it. So our assignment is going to be 3. I'm going to give us 3 assignments. The first assignment is that write a function that calculates the area of a circle. Then the second assignment will be write a function that calculates the factorial of 5. Let me just write it down so that I won't forget. The next time we meet, I'll be like, who was able to solve this? We are going to talk about the standard library function in our next class. If I go into the standard library functions, we are not closing today. So please, let's push that to our next class. But for now, let's deal with some assignments. Our first assignment will be write a function that calculates area of a circle. Definitely, the area of a circle is pi r squared. So you know that you're going to need a certain parameter somewhere. I'm not going to give you the answer. Please go and figure it out yourself. Let's write another function. Write a function that calculates the square root of a number. That's number 2. Okay. Then our final assignment will be to write a function that calculates the factorial of the number 5. Let me add one. Oh, it's okay. No, it's okay. But these are going to be our 3 assignments till we meet on Monday. Our next class is going to be on Monday. Since you have like Saturday, Sunday, like why don't I add one? You know what? I'm going to give you a question that's going to make you combine everything you have learned from beginning to end. If else, arrays, while loops. So you're going to write a function that will include all of that. So let's write a function that checks which number is the greatest among 3 numbers. We are good to go. Final assignment is going to need you to know about if else or switch statements. Okay, so you're going to write a function that checks which number is the greatest among 3 numbers. So please do these assignments for me. Then the next time we meet, we're going to find out who was able to solve it, who was not, how you were able to do it. Just to give you a few tips, this one is straight to the point. All you have to know is the formula that calculates the area of a circle. Then this one, you have to read a little small about what we are going to do in our next class, which is the standard library, because you are supposed to call a certain function which already exists in C programming. So you don't have to write a function yourself. Because how can you calculate the square root of 36.99941? You can't do that. So you need to call a certain function. It will require you to do a further research about standard libraries. So you need to call a certain function which already exists. Just a tip. Then write a function that calculates the factorial of the number 5. That also means that you need to call a certain function which already exists. And for this one, you have to combine the knowledge of writing functions and if-else statements. Yeah, basically, I think that's what you need. Or you can decide to use switch statements as well. It depends on how you want to go about implementing it. Then, yeah, I think basically that's it. So that's it for today's class. I don't know if my OBS is still working.